Hi students, here I am. I've got the leatherback turtle pulled up, and so I'm going to read it along with you, and then we'll look at the questions, and then I'll give you some time to read and annotate, and then we'll go back in and make sure you have the right answers. I won't be able to write it on this. If you have problems, you can listen to my answers as I give them to you after we get through this. Um, and if you need me to write them out and then send a picture of that, I can as well. Just let me know. Okay, leatherback turtles. Of all the turtles on Earth, leatherback sea turtles grow the largest. These amazing creatures can be 7 feet long and up to 2,000 pounds. They can also dive deeper and stay down longer than any other turtle. Leatherback sea turtles can dive 4,200 feet under the water and stay under for over an hour. Wow, that's a lot. Leatherbacks get their name from their shell. Unlike most turtles who have a hard, bony shell, leatherback turtle shells are soft and feel more like rubber. Leatherbacks have a special adaptation that allows them to stay warm in cold water. They can make their own body heat. Because of this special ability, they are found all over the world, even in the cold waters near Canada and Norway. Leatherback turtles migrate or travel. So if you look at how that's written, so leatherback turtles migrate, or travel a long distance. So it's telling you that migrate means to travel a long distance. We've talked about that before with adaptations. I just wanted to remind you how to read and understand what you're reading. So let me start that sentence over. Leatherback turtles migrate or travel a long distance to lay their eggs. They travel farther than any other turtle in the world. They can travel up to 3,700 miles one way. Like other sea turtles, leatherback turtles build nests on beaches. The mother goes to shore, digs a nest, lays around 80 eggs, and returns to the sea. The temperature determines whether the eggs will be male or female turtles. If the temperature is cooler, the eggs will be male. Warmer temperatures make the eggs female. Once hatched, they return to the water. When they get older, the female turtles will come back to the same beach place. Let me start that again. When they get older, the female turtles will come back to the same place to lay their eggs. Male turtles never return to the beach again. Humans are the biggest threat to these turtles. Humans eat the eggs. Some turtles are trapped in fishing nets. These turtles also eat floating trash because it looks like their favorite food, jellyfish. These turtles are often found dead with plastic in their bellies. That's sad, huh? Scientists all around the world are working to protect these turtles and find ways to save them. That would be a good journal, right? You could write about sea turtles and what you think you could do to protect them. What would you do if they're eating the trash, the plastic, how could you prevent that from happening, or how could you make whatever they're eating into something that might be biodegradable, that might dissolve in the water instead of just stay whole? So that would be a good journal, right? Okay, let me go to your questions to help you start thinking about it so you can go back in and find the answers. How are leatherback turtle shells different from those of other turtles? Okay, that's going to be found right there. I remember in the text. You probably remember, and it's right here in the second paragraph. Leatherbacks get their name from their shell. And if you further read through this paragraph, the second paragraph, you're going to find that right there in the text. Question 2, what special adaptations do leatherback turtles have? That's interesting. There are several. And it doesn't always say special adaptation, but if you read, it talks about how what they do is different than other animals. So let me give you some clues. Let's see. So leatherback sea turtles grow the largest. That's different than other sea turtles. So you might be able to use that. The fact that they grow so large and they can dive so deep in the water and stay under for so long, those are probably special adaptations. So when you think about that, why would they need to be able to do that? Think about where they're going in the world. Why do they need to be able to be so big, hold so much oxygen in their body because they come up to get air, but then they can stay down for a long time. Where do they go in the ocean so that they would need to be able to do that? Remember, every adaptation has a reason. So you can look there. You can look at the adaptation of their shell. And then the migrating might be related to either their shell or the fact that they are so big and can hold so much oxygen. So read those carefully. Those are all going to be special to the leatherback turtle. You can use all of that information to write in special adaptations. Why are leatherback turtles endangered? That's going to be found right here in the last paragraph. And you can see humans are the biggest threat to these turtles. There are other animals and fish that eat leatherback turtles, but if it weren't for humans, that would happen naturally in the environment and they would not be coming close to extinction. What is one thing humans could do to help protect leatherback turtles? So as I said, you could do this as a journal write, but also put a short answer here. But think about that because you are going to be making decisions when you get older that change our world. So think about things like that. Okay, so let me go on to painting my bedroom and I'll help you set this up. This is your journal, right, for today. Imagine you were a wonderful painter and your parents would let you paint anything you wanted on your bedroom walls. What would you paint? Describe what it would look like. So I want to know what you would paint, why you would paint it, why you would paint the thing you're going to paint, and then describe what it would look like. You could even do a picture on the back of that paper or on another piece of paper in your journal. I would love to see your ideas about what you would paint. And then I will just review briefly what you're going to do in math, but I'm not going to help you answer yet. So this is the countdown 7 weeks. So here we go with fractions. Write the fraction for the shaded part of each figure. So remember, think about numerators and denominators. Each of these are going to have different denominators. That's the bottom because they're broken apart differently. So I will help you with the first denominator to remind you about fractions. We haven't done them in a while. So there are 1, 2, 3, 4, 5, 6 pieces all together. That is your denominator. I wish you had your data portfolios. Maybe I can take some pictures of or make some new ones. So we have that information for fractions to help you. So this denominator is going to be 6. This one is not going to be 6. It's going to be different because it's broken into more than 6 pieces. This is less than 6 and this is less than 6. So think about your numerator and your denominator. Numerator goes on top. So you'll need that to answer that question. I always forget to change back to my mouse. Maybe by the time we're done with this distance learning, I will have learned that. Okay, number 2. Mr. Danoff checked his pocket for change. He found that he had 3 quarters, 2 dimes, 1 nickel, and 2 pennies. What fraction of the coins in Mr. Danoff's pocket were either nickels or dimes? So this is a tricky question. You're only going to be looking at nickels and dimes. How many nickels and dimes did we have? That is going to be your denominator. And then it says what fraction of the coins in sorry. No, I said that wrong. What fraction of the coins in Mr. Danoff's pocket were either nickels or dimes? So we have to look at 2 things. We have to look at the nickels and the dimes, and let me do this in blue. We also have to look at how much altogether were coins. That's your denominator. I always catch myself when I talk myself through it. Okay, so I'll help you with this. How many coins did he have altogether? He had 3 quarters plus 2 dimes is 5, plus 1 nickel is 6, plus 2 pennies is 8. My denominator is 8. Now, look at your dimes and nickels only. That's going to give you the fraction for how many coins were nickels and dimes out of coins altogether. Okay, so you finish working through that one. Number 3, write a fraction to represent the shaded part of each hole or set of holes. Okay, and I will have to refer, because looking at this, I can't tell what's shaded and what's not. So hopefully on your page, I'll have to go back and look at my page. I'll actually be able to tell what's shaded and what's not, because I can't tell from this one. It all looks the same color. So I'll help you with that when we come back through. Number 4, Terrell makes a number line from 0 to 1. Then he divides the number line into 6 equal parts. What 5 fractions will he write at each mark between 0 and 1? So he's making a number line from 0 to 1. Let me help you make a number line from 0 to 1. Hopefully yours is straighter than mine. 0, and I'll put 1 out here. Okay, let me use a different color pen to do my numbers. Here's 0. Here's 1. Okay, so then it says he divides. That's an important word. It has to be equally divided. Do the best you can to make it look equal. He divides the number line into 6 equal parts. What 5 fractions will he write at each mark? So there's going to be 6 equal parts between 0 and 1. So I'm going to cut it in half just to make it look, so I can try to do it as evenly broken apart as possible. So there's my first. So let's see. So I know I have to divide it in 6 equal parts. Remember, we're going to count spaces in between. Okay, let me get a different color. Spaces in between. 1, 2, 3, 4, 5, 6 spaces. That's supposed to be up above. 6 spaces. That means I've got 6 spaces, so my denominator is going to be 6. But what we're doing is we're labeling each line, each red line. Okay? I'll give you another clue. At 1, remember a fraction that's equal to 1, if our denominator is 6, it's going to be 6. That's a 6. Let me try to make it a better 6. 6 over 6. When your numerator and denominator are the same, it equals 1. So I'm going to put that here. Okay, so if that's true, what is going to go here? What's going to go here? What's going to go here, here, and here? The denominator is always going to be 6 for this number line. That's your clues. That's all I'm going to help you with for now. Number 5. Beta bought 6 bunches of radishes. Each bunch has 7 radishes. So she's got 6 bunches. So I'm going to draw circles for 6 bunches. 2. I don't know if I need to do this yet. Let me see if I even need to do that. I might erase. Each bunch has 7 radishes. How many radishes does Beta have in all? Okay, yeah. So I've got 6 bunches. You could do an array. It says you can draw an array. So I'm going to first do my groups, and then I'll show you an array out here. I don't want to do everything for you, but remember, I'm going to try to do this the best I can. So an array is going to be rows and columns. So if it's going to be an array, I've got 6 bunches of radishes. Each bunch has 7 radishes. So I'm going to do my bunches as rows. Again, I'm going to try to separate it evenly first. So each row is a bunch of radishes. If we're doing an array, I did groups over here just so that you would see how many there were in all. So now I need to break it apart into each column being, I'm going to do a different color for my columns, being a radish. So there's 1 radish, 2, 3, 4, 5. Oh, they're pretty even. I'm pretty impressed with myself. Pretty good. Okay, so 1 radish, 2, 3, 4, 5, 6, 7. So I've got 7 radishes in each row, and I've got 6 rows. So there you go. That's how many radishes in all. If you drew it like this, make sure you put it into an array because that's what it says. But this will help you figure out how many you're going to need. So if I've got 6 bunches, I've got 1, 2, 3, 4, 5, 6, 7 in all in each bunch. So if you've got 6 bunches with 7 in each, how many do you have all together? Okay, start solving that, working that one through. Oh, look what I did. Forgot I had my drawing tool. Okay, here we go. Part B, write a multiplication sentence that represents your array. Then solve the problem. You can do that on your own, and I'll check back in with you. Adding, subtracting 3-digit numbers, you're going to be doing the same processes that we've been doing. So I will correct this and take a picture and upload it so you can see it later, but I want you working it through. So what I want you to do is just like we do when we do this in class, do all the problems. Then when I give you the correct answers, circle the ones that you need to fix and fix them. Okay, so that you are seeing what you're doing wrong. That's the most important part. I want to know what you're doing right and what you're doing wrong. So for example, start by looking at the sign. It is a minus sign. So 1 minus 8. I can't do that. I've got to borrow. Makes that a 7. Regroup that here. So I'm adding that group of 10 here to my 1. That makes 11. 11 take away 8 is 3. 7 minus 2 is 5. And 8 minus 5 is 3. There you go. So I want to see the regrouping, whether it's subtraction or you are adding to regroup and you need to regroup. Like on this one, you're going to need to regroup. I can tell right now. 9 plus 5 is going to be 14. So put my 4. Regroup my 1. So 14 has a 1 and a 4, right? The 1 is in the 10, so regroup it to the 10s. So 8, 9 plus 5 is 14. Oh, 14 again. There's a 4. So in the number 14, we got to regroup that 10 over here. 10 tens is 100. So 8, 9 plus 9 is 18. Regroup that 1 to the thousands. And your answer is 1,844. Okay, I will be back in a bit to correct this. And then I'll finish correcting and posting anything that I haven't done for this week. And I will talk to you soon.